All right, so I'm going to streamline. We'll call it that, okay? I'm going to streamline this lesson a little bit, leave out some of the stuff they put in there. I'm going to get right to the basics and show you how to do some of these problems, all right? So we're going to talk about three types. Direct, they call it variation, or what was the word that I used? Proportional, directly proportional, inversely proportional, or this thing called joint variation. So when we talk about direct, so let's write that down. So when we talk about something being directly proportional or a direct variation, let's see what word they use here. I think they say it varies directly, okay? So when you see that word direct or direct variation, yeah, we'll call it direct variation. Oops. This is how you're going to start it off, all right? So direct variation would be like y equals mx plus b. You've heard that before, right? Y equals mx. That's a direct variation. So instead of the m could be represented by something else, a constant. And they use the word K, or the letter K, for constant. I know constant starts with a C, I get that, but a lot of times they have this constant, they use the letter K. You're going to see that quite a bit. If you take physics and stuff like that, you'll see this kind of thing. So when it's a direct variation, the x and the y are on the same line, okay? They're both in the numerator. So this is a direct variation. So if one thing moves up, then the other thing moves up, all right? So as x gets bigger and bigger, then y gets bigger and bigger. Everybody with me on that? Now, it depends on what the k is, on how much bigger it gets, all right? If it's like a 2, right, it slants up more, like y equals mx, right? Y equals mx plus b. If you just had a 1, your slant would look like this. If you had a 2, your slant would look like this. So that's all it does, is just change how much, right, it changes, okay? You with me on that? So that's direct variation. Now the inverse, or if it varies inversely, you'll see that in these problems where it says y varies inversely with x. So if you see that inverse phrase, or inversely, just put inverse, okay? An inverse variation, that means as one thing goes up, then the other thing goes down, all right? It's an inverse, all right? So this is how we do it here. So this is very general. You could use other letters. This is just very general. So I'm going to put k over x. See how the x is on the bottom, the y is on the top? So look at this. As we've talked about this before, as x gets really, really big, what happens to the y? Does it also get very, very big? Look, this is the denominator. As the denominator gets bigger and bigger and bigger, 1/2, 1/4, 1/8, 1/16, 1/32. What's happening to that actual value? As the denominator gets bigger, the fraction's getting what? Smaller, okay? Do you see the inverse variation? As one goes bigger, the other goes smaller. Yes? Okay. As this one, as x gets bigger and bigger, what happens to y? It's a direct variation, so it's what? Y gets bigger and bigger and bigger. And so, and if x gets smaller and smaller, y gets smaller and smaller. If x gets smaller and smaller, what happens to the y? It gets what? Bigger and bigger. It's the inverse. Everybody got that? Okay, so that's pretty much what you need to know for there. And then they have a joint variation, which means you could have a joint variation means we're going to have more than just the two variables, more than just the x and the y. The k is really not a variable. The k is a constant, okay? So it's not really a variable. So joint variation, what does that mean? So that means like y equals k, and then you might have an x and a y or z in there. Okay, it could be other letters. It doesn't have to be x and z, but you might have a couple things in here. Instead of just y varying with x, it also varies with z as well. With me on that? Sometimes they'll say y varies directly with x. You just write y equals kx. But sometimes they'll say y varies directly with x squared. How would you write that? Y varies directly. So you've got to have that constant. So you keep the constant right there. It varies directly with x squared. So you just write what? X squared. Simple. Okay, you could have something that says y varies inversely with, or it might not even use y. Let's use another letter. It might say that a varies inversely with the square root of b. So how would you write that? It's inversely, so you're going to have a fraction. Your constant's going to be up here, and if it says the square root of b, then what do you put here? Put it on the bottom, because it's an inverse relationship. Make sense? So that's the kind of stuff you're going to see. You're going to see it's like a little word problem, and they're just going to say this varies somehow with something else. So that's what you're going to write down. And then what they're going to do is this. They're going to give you the x and the y, and you're going to have to find what? You're going to have to find the k. All right? You're going to say, all right, this is your constant. It's kind of like your slope, right? That's the closest thing that I can think of that we're familiar with. All right? So it's kind of like the slope. And then what they're going to do, they're going to give you some other values for x and y. So you're going to find what the k is. You're going to use that k. Then they're going to give you other values for x and y, and you're going to put that k into it and then solve for whatever they want you to solve for. Now that sounds kind of wordy, but let's do an example. Let's look at example 1. Now, if you look at the examples and how they do it a little differently. But again, I'm trying to streamline this so we're all kind of doing it the same way. I'm doing it a little different than what they do it in the book for the examples. But I think this is a good way to do it. So example 1. It says, suppose y varies directly as x. So that's pretty easy. What if you hear that phrase, you see that phrase on your homework? Suppose that y varies directly as x. How do we write that? Y equals what? Kx, that's right. Okay, so that's what you write down. So when you see the phrase y varies directly as x, this is what you write down. It's not too hard, right? All right. And then they're going to give you some stuff. They're going to say, and they're going to tell you some stuff. They're going to tell you what x and y is. They're going to say, and y is equal to 27 when x is equal to 6. All right? Now, there's a little bit more to it. Okay? They're going to say, find the value of y when x is equal to 10. All right, so they give you all this information when x is equal to 6. But then they said, okay, let's keep that same variation. But what happens when x is, oops, I should put this when x equals. What happens when x equals 10? Remember that, again, I'm just using slope just for an easy example so we can remember. But whatever our constant is, we'll call it slope. Whatever our constant is, it's going to be the same for this over here. So every time I give a different value for x, I can figure out what y is because I know what my constant is. All right, so that's the key right there. That's the first thing we find is that k, that constant. So let's do that. Let's find that constant. So here's my little equation. Okay, this is my y, this is my x, and I can solve for k. On this problem right here, you might not have to do it, but some of them get a little bit more complicated. So the book doesn't do this, but I do this. If you want to just put the numbers in, watch. If you just want to put 27 in for k, or I'm sorry, for y, keep that k, and then put the 6 in for the x, you could do that. But what are you going to have to do? You're going to have to divide both sides by 6, correct? And then go from there. So what I do is this. And you might look at on this example and you're like, well, why go through all that? It'd be a lot easier to just plug the numbers in. But there's something going on. Must be WWE. It's like WWE over there. I don't know what's going on over there. So anyway, I'm trying to block it out. So you try yourself to block it out. So what I'm going to do is I'm actually going to get k by itself before I stick the numbers in. All right? hopefully, do they offer physics this year? I don't even think they do they? Hopefully next year they'll have physics. Okay, I taught physics for a few years back at my other school, quite a few years. And sometimes you get this big long formula, and instead of plugging the numbers in and then finding that one variable that you're supposed to find, I like to do this. I like to actually solve for the variable first before you stick the numbers in. Okay, find what the variable is equal to, come up with a little equation, and then once you come up to that equation, then you plug all the numbers in. So that's kind of what I'm doing right here. So I want to get k by itself. It's very simple. How do I get k by itself right there? Divide both sides by x. So what's k equal to? It's equal to y over x. Do you have to do it that way? No, you don't. But I just think it's good to get used to doing that. So get the k by itself. Now you can just plug these numbers in and work it out. Okay? Does that make sense? You could do it this way, right? You could plug both the x and the y in right there and then go ahead and do your algebra with the numbers. But I like to do it this way. So what is the y? It's 27. What is the x? It's 6. We still would have gotten the same thing here, wouldn't we? All right? It's still the same thing. But I just think it's a good idea to get that k by itself first because they're not going to be a whole lot more complicated, just a little tiny bit more complicated later on. And I don't know, I just found myself just getting k by itself. I just thought that was the easiest way to do it. So that's what I'm going to do. So that is 4.5. Okay, you can keep it 27 over 6 if you wanted to, but it's 4.5. That's what k is. Is that my answer? No, because they want you to find what? They want you to find y when x is equal to 10, not when x is equal to 6, when x is equal to 10. So now I know what the k is. I know my constant. So now I can solve for y. Y is already by itself right there, so y equals k times x. I just found k. What is it? 4.5 times x. What's my new x now? It's 10. So I put in a 10 right there, and then I just multiply it, and that's my answer. That's just 45, and there you go. All right, so when x is 10, you could think of the graph if you wanted to. Y is going to be 45. If x was 6, y is what? 27. All right, and you could put any numbers in there if you wanted to, as long as you know your constant. So that constant right there, that's a really important thing to find. That's the first thing we find, and you're going to find that these problems are just like this. I mean, there's a little bit of a switch. Sometimes they'll say inversely, sometimes they'll say joint, sometimes you'll have a combination of direct and inverse in there, all right? So that's the kind of stuff that you're going to be doing on your homework. It's really not that hard. Would you agree? It kind of looks like normal math now, doesn't it? A little bit better. All right. So let's do, I'm going to skip example 2. It's a big long word problem. Doesn't mean it's not important. It's actually probably the most important one of them all. But as far as doing the homework problems, you're really not going to see that. So let's jump to example 3. All right, so the problem says, if y varies directly as the cube of x. Let's write that down. Y varies directly as the cube of x. How's that going to be written? You got it. Very simple. Everybody see that? So y varies directly. You got to have that constant in there. Don't forget that. Y varies directly, okay, as the cube of x. All right, so everything still stays in the numerator there. Everybody with me so far? All right, and then they tell you a couple things about it. They say y is equal to negative 67.5 when x is equal to 3. All right, so they give you an x, they give you a y. What are you going to solve for? You're going to solve for k, correct? But then they put some more to the problem. All right, so now they say once you found k, then find x when y is equal to negative 540. They put the word when in here. I didn't, but I'll put it now. Okay, find x when y is equal to negative 540. Everybody ready? All right, so let's do this. Let's solve for k. I'm going to get k by itself first. Again, you could just plug the numbers in right now if you wanted to. It's fine. No big deal. This is just how I do it. So if I want to get k by itself, what would I do? Divide by what? Well, x cubed, before I put the numbers in, okay? I want to do the algebra with the letters before I put the numbers in. I just want you to get used to doing it that way, because there's a lot of times where I think it's better to solve for the variable before you start plugging stuff in. All right, so now let's go ahead and put the numbers in. So this is negative 67.5 over x, which is in this case 3. It's 3 cubed. And let's see, what do you get? I did this a completely different way, so I don't even have this written down. So let me get my calculator out. So 67.5 negative divided by, is that 27? So it's negative 2.5, negative 2.5. All right, everybody with me? All right, we're not done. We got to find x, correct? Now, if you wanted to, you could plug everything into this, or you could just solve for x right now. Do you think you can solve for x? What would I do first? Well, not yet. Yeah, divide by k. So I'm going to get x equals y over k. But then you got to get rid of the cube. Now say it. Cube root. Okay? Put a little cube right there. We good? Now, to me, I think it's a lot easier just doing the algebra with the letters, okay, and then plugging stuff in. I've said that 100 times a day, it seems like, but I just want you to understand why I'm doing that. All right, so it's the cube root of y. What's my new y? My new y is what? Negative 540 over the k. What did I get k to be? Negative 2.5. All right, and I chuck that all into the calculator, and I believe you get 6. Can you believe that comes out to a nice number? So x equals 6. And that's what you do, okay? Definitely use a calculator for this stuff. Some of them you can do without a calculator, but a lot of them, calculator is very helpful. All right. Did we do an inverse one yet? Oh, yeah. Example 4 has an inverse in there. And then I'll let you start working on the homework. This one says, if y varies inversely as x, y varies inversely as x. How are we going to write that? It's an inverse variation. So how did we write it? Look at your notes. Are you just not answering me, or you just don't know, or what? Y varies inversely as x. This is how you would write it, just like that. Okay, it's inverse, right? The y is on the top, the x is on the bottom. That shows it's an inverse. Everybody okay with that? Yeah. All right, we'll see. So, and then it says y equals 21 when x equals 15. I'll leave out the when, I'll just put it like that. And then the question is, find x when y is equal to 12. Again, if you look at how they do this in the example, it's going to look a little different. All right, I just think I weighed it between the two ways, and I think doing it this way is better. It gives you the same exact answer. All right, I just think this makes a little bit more sense. So we're going to do it this way. So if you do look at the examples, they do it a little different than I do it. So what are we going to do here? Solve for k, correct? So can I get k by itself pretty easy? Yeah, multiply both sides by x. So k is x times y. You could have just plugged those numbers in and then solved for k if you wanted to, but I like this way better. So what do we got? 15 times 21, whatever that is. That's, actually, again, I didn't write that. I did it a different way on the example, but then I changed how I was going to do that. So what's 15 times 21? 315. All right. So we're going to use that 315 over here as well. So here's we want to find a new x when they give you a new y, but our k is going to stay the same. It's a constant. It's going to stay the same throughout the whole thing. All right, so we got to find x. If you want, let's get x by itself. Can you do the algebra and get x by itself right here? Can you do that in your head? Look, multiply both sides by x, right, to get it over on the other side. So x is going to be on the top. How do I get rid of that y? Divide by the y. So what's it going to be? K over y. You can do that in your head, can't you? Should be able to at this point. Now we can just plug the stuff into here, and then we got x. So what's our k? Well, we got it over here earlier. It's 315. And then what's the y? Well, the new y is the 12. So put the 12 right here. So that should be 26.25. Is that right? Anybody try that? 315 divided by 12. Yep, 26.25. Yep. All right, so that's basically how you do these things. They give you another example. But I think we're good. Yeah, I think that's good. All right, if you can do what we did today, you should be able to do all these homework problems, okay? They're pretty much like this. Sometimes they get a little bit more complicated. They might throw another variable in there, okay, with a joint. But they'll say, I'll just make something up. Let's say y varies directly with x squared and inversely with z cubed, okay? Does that make sense to you? So this means y varies directly with x squared, because the x squared is on the top, and inversely, that means that goes on the bottom, with whatever letter they tell you, z. They tell you that it's cubed, right? So what if you had this? What if that's the way you set it up, but you wanted to get k by itself? Everybody looking here? So watch. This is about as complicated as any of the ones on the homework get. It might be something very similar to this, but you got to get k by itself. So let's do that. If I get k by itself, what do I have to get rid of? Well, let's get rid of the z cubed. How do I get rid of the z cubed? What? Multiply both sides by z cubed. So you got the y over here, and we're going to multiply it by z cubed. All right, so I got rid of that. How do I get rid of the x squared if I want k by itself? What? No. I want to get rid of the x squared, not the x. I don't want to get x by itself. I just want to get rid of that x squared. What's that x squared doing to the k? It's multiplying. How do I get rid of something that's being multiplied? I divide. So I divide it by x squared. You should just be able to look at those and then just write down the formula. Everybody see that? This was on the bottom. Where does it go on the other side? On the top. This was on the top on this side. Where's it going to go when I put it on the other side? On the bottom. Do you agree that's what happened here? Yeah. And now they're going to give you a y, a z cubed, and an x. Well, they'll give you an x and a y and a z, right? You just plug it in, solve for your k. Then they're going to give you a new, like either x or z and solve for y, or you're going to solve for x, or you're going to solve for z. And then you just plug everything in. That k stays the same. Yes, ma'am. The homework? There you go. Is that right? Yep, 194, 13 to 24. That is correct. So page 194. What did I say, 13 to 24? And it's section 3.8. Look at that. It's a miracle. It's a pre-calculus miracle. We finished a whole lesson in one class period. All right. So there you go. All right, so get that done. That's going to be due on Monday. And you got about 12, 13 minutes left in here. So let's use the time wisely. Let's try to get as many of these done as you can. If you have any questions, now's the time to ask questions if you have any. Okay?